This is PreCalc 12, Chapter 8.2. This time we're going to be looking at permutations of different objects. And to permute means to arrange. Permutation is to find all the different ways to arrange objects, so order is important. This is a slight variation of fundamental counting principle. And the difference is these are dependent events. How many ways can the letters of the word hat be arranged? So we have hat, we have HTA, we have AHT, we have ATH, we have TAH, and we have THA. Okay, we have 6 ways. And we have really 3 ways to pick the first letter. We only have 2 ways to pick the second letter. This is because the second letter is dependent on the first letter. We can't choose the first letter again, so that's why it's dependent. And really, we have no choice for the last letter. So, using a chart is okay for small sets, but what if the sets get bigger? Okay, so we can generalize this for any n objects that are in the arrangement. And it's n times n minus 1 times n minus 2, dot, 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 all the way to 3 times 2 times 1. And there's actually a function for this operation, and it's called factorial. And the notation is n exclamation mark. And by definition, we have 0 factorial is equal to 1. So, how many ways can lucky be arranged, or the letters of lucky be arranged? And this is simply 5 factorial. And this is 5 times 4 times 3 times 2 times 1, and that's 120. On our calculator, if you press math and scroll over to the third one, and down to 4, that is the factorial sign. So you enter 5, you go to math, probability, exclamation mark, and that gives you the answer 120. So if you only pick R objects from a set of n, then the formula is a little bit different. We go n times n minus 1 times n minus 2 dot 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 all the way to n minus r plus 2, and finally n minus r plus 1. And the notation for this is n pick r, or n permute r. This is n factorial over n minus r factorial. N must be bigger than or equal to r. So, for example, how many ways can object be arranged when only choosing 3 letters? So we have 6 pick 3. Write these as subscripts. Okay, so they shouldn't be the same size as the letters. They should be below. So this is 6 factorial over 6 minus 3 factorial. So this is 6 factorial over 3 factorial. And you can use your calculator, but for small numbers, things cancel out quite nicely. So we have a choice. We can do 5 times 4 or 5 times 6. Let's do 5 times 4, that's 20. 20 times 6 is 120. You could have done 6 times 5, that's 30. 30 times 4 is 120. Next example, there are 9 teams in the Western Conference of the MLS. How many ways can the playoff standings be arranged if 5 teams make the playoffs? Okay, so this is 9 permute 5. So we 9 factorial over 9 minus 5 factorial. So this is 9 factorial over 4 factorial. And by now you should see that things cancel out and we can just simplify them 9 times 8 times 7 times 6 times 5. I'm not going to try to do this one in my head. So if you don't have factorial on your calculator, make sure you cancel everything out and then just type this in and you'll get 15,120. On your calculator, you can use n permute r with this button. So probability number 2. So enter the 9 first, then enter NPR, and then enter 5, and then press enter and you get this answer. Next example. There are 12 horses in a race. How many ways can they finish first, second, and third? And this is win, place, or show if you are into horse racing. So this is 12 permute 3. This is 12 factorial over 12 minus 3 factorial. So this is 12 times 11 times 10. And we can do this in our head. 12 times 11 is 132. So there's 1,320 ways. Okay, let's look at something a little bit more complicated. This is called arrangements of arrangements. So sometimes you need to keep things together. For example, you have 4 families sitting in a row of seats. And the families have 5, 4, 3, 4 members each. And the restriction is each family needs to sit together. So how many arrangements are there? Okay, so let's arrange each family first. So we have 5 factorial, which is 120 ways to put this family of 5 together. And we have 4, so that's 24. We have 3, and that's 6. And we have 4 again, so that's 24. Now, we can arrange families F1, F2, F3, F4. Okay, so we are permuting these 4 families. So that is 4 factorial ways. Again, that's 24. So now we can use the fundamental counting principle. So we have 24 times 120 times 24 times 6 times 24. And that gives us 99,53280 ways. And that's a lot of ways. So that's just under 10 million. And we should do a check. If there wasn't a restriction that the families had to sit together, no restriction, then we would have 5 plus 4 plus 3 plus 4. That's 16 members. So that would be 16 factorial. And that is a much bigger number. That's 2.09 times 10 to the 13 ways to sit together. Okay? This is much larger. This has 6 zeros. This has 13 zeros. Since this is 2, we can just take away 1. So 12. We have double the number of zeros. So we have 1,000,000 times more ways to arrange this. Okay, let's look at a backwards problem. Solve for n. N permute 3 is equal to 210. So we have n times n minus 1 times n minus 2. And we know this equals 210. This is n cubed minus 3n squared plus 2n. That's 210. Let's look at this. What are the factors of 210? We have 2, we have 3, we have 5, and we have 7. And we must note that there's no way to get an 8. And we're looking at a factor property. Okay. So we have 7. So this must mean we have 7 times 6 times 5, and we just test that out. And that's 7 times 30, and that indeed equals 210. So n equals 7. And you can always check 7 permute 3 equals 210. So I worked this out mentally. If you are stuck, use trial and error. Okay, you can try 10 permute 3. That's 720. That's too high. So then you can try 5 permute 3. You see that that's 60, and this is too low. Then you go, okay, let's try 8. That's 336. Again, too high. And then you would try 7 permute 3, and you would find that's 210, and then you can stop. On a test, you need to show it these steps. And you want to show these steps so it shows that you're working on it and not just pulling this number out of the air. And that completes this lesson.